All right, it's now 10 o'clock Central European time. So hello everyone, and thanks for joining our webinar today. If you have questions during the session, please submit them using the Q&A button at the top of the interface. Those questions will be answered at the end. This webinar will be recorded and you'll receive a copy of it delivered to your email account. I hope you enjoy, and I'll hand you over to our experts, Lars Knoll, who is the Qt Chief Architect at Qt Company, and Tuukka Turunen, who's the SVP of R&D at the Qt Company. Over to you guys.
Thanks. Good morning. My name is Tuukka.
Yes, and good morning from my side as well. Lars Knoll speaking. It's great to have you here on the seminar. We'll start with going a little bit through Qt 6 and what's happened over the last year and all the good news stuff. Tuukka will talk a bit at the start about the general roadmap and some things related to Design Studio and Qt Creator. I'll be walking you then later on through the features in the Qt framework of Qt 6. Tuukka.
Yes, let's see how the slide sharing changing works. Yes, success. So Qt 6 timeline. Let's look a bit on this. So as most of you probably know, Qt 6 as a new major version of Qt was started already a while ago. We started obviously with thinking of what kind of things there are that we really should have in the next major version. Lars will be talking a bit later on also on the fundamentals of why we chose to do some things and what were the key criteria there that we selected. We also looked that, okay, when do we need to do Qt 6, because even though we have put a lot of effort into making sure that the discontinuity is as small as possible, there always is this, and we need to make it so that, like, oh, if there is something that we can add easily to an existing version, of course that's much better for the users than only having it in the new version. So we during the lifetime of Qt 5, we actually have done quite a lot of things, and many of you may remember that somewhere around the mid-lifetime of Qt 5, we even switched to the new version of C++, and we did quite a big changes there. So kind of second generation Qt 5 within. But now with the major version, we are able to tweak many of the internals that are not possible to do in a feature release, and this is where we have been focusing on and making sure that the path is set. So in 2018, 2019, we were doing the first concepts, starting the development of the key items based on the research that was done. And then last year was the main year of the feature development, where we, of course, some of the people that are working with Qt had to work also on Qt 5.15, which is the current long-term supported release, and of course a release where basically everybody is, unless you are in a earlier version of Qt. And that's, of course, took some time still in the beginning of last year, and then towards the end of the year we have been able to move full focus to Qt 6, except of course we are still maintaining and fixing bugs on 5.15. That takes some time. Good thing is that many of the things on Qt 6 and Qt 5 are very similar. So when we fix a bug, first of all, when a bug exists, it oftentimes exists in both. And then when we fix a bug, the fix can be applied to Qt 6 first, and then cherry-picked back to Qt 5. So we had the first release of Qt 6 coming out in the December, and we are now quite soon releasing the first batch release of a Qt 6, so 6.01, probably somewhere next week. And then also this year, and of course we continue releasing those batch releases, and this year we are also then releasing the first feature release, Qt 6.1, and then the first long-term supported release, Qt 6.2. And of course, one of the key items is being able to bring more of the add-ons that we had in Qt 5, but we are not yet supporting in Qt 6 back available for the users. So one thing I would like to talk a bit is a package manager. So a bit rough drawing, but I hope this gives the base point that what we are aiming to do. So whereas with Qt 5 we had the selection of over 50 different modules coming with the same installer, and then also we had some additional content coming from marketplace, and from also there are some third-party content that many users are taking. So how to ensure this as a more flexible approach? So what we are now creating is that we have the base installation of Qt 6 a bit smaller than it has been before. So basically consisting of the essential modules and a few selected add-ons that are kind of essential or at least used by a really majority of the users. And then those add-ons that are still important but not always used or used by a smaller amount of users, we are distributing via a package manager. So this gives us flexibility to also distribute much more add-ons than earlier, and also it gives the flexibility of working with content that comes from different sources, like for example the marketplace or from external repositories or wherever, basically using the package manager functionality. With Qt 6 we had only a couple of these additional libraries, 6 to be more precise, are currently available, but more are coming as those add-ons are completed during this year. We are also still using a bit rudimentary setup. So the package manager that we are using is Conan. We don't have a Conan server as such, but we are using the installer still to select. But we going forward, we would like to have also the package manager backend established separate to the installer, and obviously the tooling side. So Qt Creator, how you handle those parts in the IDE and with the build system, those are also being developed forward constantly. So the basic setup is in place and it works, but there are many things that we can do to make it more easy and intuitive to use still. So this is the idea also for the additional libraries, and our vision is that this allows us to really make the lives much easier for the users to basically having access to a larger amount of content than is coming with Qt 5. Speaking of those essential and add-on modules, so with Qt 6, the green one that is now already released contains a bit over 30, I think 31 to be precise, modules, mostly the essential modules, and then some of the most used add-ons. This is already there with, and then looking at the add-ons of the Qt 5, we have selected 20 of the most important ones, which pretty much consists of all of those. There are some that were deprecated, and there are some that we are still seeking a way what would be the best way forward with them. But those add-ons that we are then bringing throughout this year. And the current plan is that with Qt 6.1, we should be able to bring those mentioned ones, and then the remaining set of this year's add-ons would be coming with 6.2. Of course, if they are ready earlier, the package manager approach gives us the possibility of basically offering them as soon as they are available. One of the benefits is that it also gives is that an add-on can, if needed, have a different life cycle than Qt, and it also gives a possibility and flexibility of using the same add-on across multiple Qt versions, which has not been feasible so much before. So that about the timeline and the installation. Now a bit about the designer tools, and after that developer tools, and then we move over to Lars for the Qt 6 framework content. So Qt Design Studio 2.0 was also released in December. Available, supports Qt 6. provides multiple nice features. One of the greatest things that it provides is a unified 2D and 3D design tooling. So you can import your assets from a large number of different 2D, 3D graphics design tools and formats, take it in to Qt Design Studio, and then use the visual editor to put those both the 2D and 3D items in place into the same app. And also they can be mixed both in the design, but also during the runtime, now that Qt Quick 3D and Qt Quick 2D are sharing the same setup with Qt 6. Then another item that is important on the Design Studio is, let me get the full slide visible, is about being able to support across your whole product line. So with Qt Design Studio, you can obviously target the Qt, but you can also target the Qt for MCUs on the low end. So with the same tool, same code base, same kernel language, you can create your app that runs across a lot of different kinds of hardware and across also a lot of different kinds of price points in the hardware. And you can more easily manage your whole development cycle, starting from the very low end microcontrollers to the high end application processors with the powerful GPUs for fancy 3D effects. So then, and I recommend you to take a look on the, and also you can create companion apps, of course, desktop apps as well, with the same setup with Qt. So I recommend you to take a look on the Design Studio, take it for a spin, see how it is. I believe that this is quite valuable for many of our users. Then just a few words about the developer tools. Qt Creator 4.14 released in December, fully supporting Qt 6. Already the previous version of Creator was providing quite good Qt 6 support that we used during the development of Qt 6, but now it's there fully. You have the wizards to generate Qt 6 compliant projects. You can use the debugger with Qt 6 types. Of course, the editor knows all the new QML, C++ language features. You have the Qt 6 documentation examples packaged in, and you can fully develop the Qt 6. Of course, there are many things that we are still doing during this year and improving, but everything is there for the Qt 6.0 to be used with Qt Creator as the developer tool. Qt 6 brings a new CMake build system. Well, okay, Qt 5 was possible to be built with CMake as well as QMake, but we basically flipped them around so that CMake is now the primary build system that we use also to build Qt, and QMake is supported for the applications as well. So we have been improving the CMake support in Creator as well. Lars will be talking a bit about CMake in Qt in his part, but we have with Creator 4.14 we have improved the Git detection, and we have also allowed reuse of the existing build directory. We are supporting kernel debugging profiling, and of course, as I mentioned, it's completely fine to still use QMake in your app if you want, but we recommend taking a look on the CMake and gradually moving to that, because it does add a lot of value that we are not able and we don't want to bring with QMake. So benefiting on all the work that others who use CMake is something we can now take advantage of as well. Another item where we are benefiting from work that others are doing in addition of us is using the CLang code model. We have updated that to CLang 11. We have improved the refactoring operations for C++ development, and we also are improving and more tightly integrating with the Glazy and Clang-Tidy tools that are provided. So these and other improvements in the C++ development throughout the Qt Creator 4.14 are available when you take it for a spin, and this is the recommended version of Qt Creator to be used together with Qt 6. that was all that I had prepared, and I will be available for questions together with Lars at the end. But now, Lars, over to you for the Qt 6 framework topics.
Well, thank you, Tuukka. I will talk a little bit about now what we have done on the framework side. As you've seen, there are lots of things that have been happening also around Qt. The way we are packaging Qt, we're distributing Qt through the package manager that Tuukka has been talking about. For Qt Design Studio and Qt Creator, we've done a lot of work also, of course, to make it ready for Qt 6, but also to add new features. But let's go a little bit into Qt 6 and start off with a high-level picture of what has been motivating us to do that work, to do the jump over to Qt 6. What have been our goals? What kind of things have we taken care of when we moved there? The goals for Qt 6 have been really to fix some of the architectural limitations that we have been seeing in Qt 5. We released Qt 5 around 8 years ago in 2012, end of 2012, with a lot of things and assumptions that where the world has been changing around us in the meantime. Things like, especially on the graphics side, the graphics architecture, we've been putting ourselves behind OpenGL as the graphics API for 3D graphics. As we all know, the world has changed, and OpenGL is not the one thing you can use on all platforms anymore. There's a diversification that has happened that we needed to address. We wanted to also go in and improve performance in certain areas, things we couldn't do without breaking some level of compatibility. There's the house cleaning, something that is good to do every couple of years. Remove deprecated functionality, clean that up so that we can actually move forward faster and implement new things that are required faster moving forward. Tuukka talked about the package management support and the smaller and more modular core product that we're having now. And then finally, one of the goals has been also to make sure that we're really compatible with Qt 5. When doing these kind of larger changes, it's always important to keep a little bit in mind, okay, what the most important things are that we need to actually maintain. What's the core value proposition of Qt for our users? And there are a couple of ones of those. The cross-platform aspect is certainly extremely important. It's one of the things that we have had for all the years in Qt, making sure we isolate our users from platform changes in the underlying platforms. Maintainability, compatibility, that the code you write using our frameworks is maintainable, that we keep compatibility and you can easily move from one Qt version to the next without having to worry about that. Scalability, you can do things on very low-end hardware embedded devices, and it scales all the way up to rather complex desktop systems and everything in between. Intuitiveness and ease of use, of course, something that still is extremely important for us and continues to be extremely important. As how can we make our APIs easy to use? How can we make our tooling easy to use so that development actually is as productive as possible and as much fun as possible? A great documentation. I think this is one of the things that really stick out with Qt compared to many other tools. And of course, then the tooling around it that binds it all together and brings it all into one big package. Having said that, the focus for us really has been on cleaning up our code base and the architecture in Qt, and not on new features with Qt 6. So Qt 6, while it does have quite a few new features, that has not been the main focus of the work that we've been doing through the last year. The main focus for us was to prepare Qt for the future, for the years to come, and make sure that the framework actually renews itself and is something that you also want to gladly use in a couple of years from now. We've worked very hard to make, while we're doing all those architecture changes, to keep the source compatibility with Qt 5 as much as possible. There's, however, some porting that will be required when you do the move from Qt 5 to Qt 6. It shouldn't be a whole lot, but there are some changes that you will see in the source code, especially when it comes to you still using functionality that had been deprecated in Qt 5.15. It will, of course, require a deprecate, a recompile, and you'll have to basically bring your API or the usage of Qt up to the latest standards, remove all the deprecated API calls that you might still be using. With that, let's have a little bit more of a deep dive into 6.0, what's new there. And it's important to note that 6.0 is a starting point for us. It's something that we start with, and that is the starting point for a whole new series of Qt releases. So not everything is done in 6.0, as you've seen with Tuukka. There's a couple of modules that will now come only with 6.1 and 6.2. And those are things that we're working very much on. The first big new change in Qt 6.0 is that we are now requiring a C++17 compliant compiler. With Qt 5.6, we did a switch from C++98 to C++11. With Qt 6.0, we're now doing the next big step and moving all the way up to C++17, which means Qt itself is using all the features that are available in C++17. Things like structured bindings, if const expr, template argument deduction, new standard library features, and a lot of other things. Those are things that we are now using internally in Qt, and they help us simplify our lives, and they also make it possible for us to offer nicer and better APIs to you as our users. Let's start off at the bottom, at the low level functionality that we have in Qt, and have a look at those things. One thing that has gotten a lot of attention from our side is the container classes that we have, all the template classes, templated containers. And we've done a lot of work there to close the API gaps towards STL containers, have, for example, consistent support for move operations, things like mplace have that implemented, support for initializer lists. We've removed the 2 GB size limitations that we had on our containers in Qt 5. So now sizes are measured not in integers anymore, in 32-bit integers anymore, but in Qt size type, which means on 64-bit platforms, you can use a lot more than 2 gigabytes of items in there. We've changed the default constructors to be const expr and non-allocating. That is very nice feature in many cases when you want to initialize your classes and you have containers as members in there. We've completely reworked QList and QVector. Those have been 2 classes serving mostly the same purpose in Qt 5, but they had subtle differences in how they were behaving and quite different implementations. We've decided in Qt 6 to merge them to simplify our APIs. They're one class now, and QVector is actually an alias to QList. This really simplifies our API, and it also removes some performance issues that we had with QList in Qt 5. We're now using a vector-based data structure, and it improves the performance in pretty much all cases that we've measured. It's almost 100% source compatible. There's one exception. There are in QList, in some cases, references you could keep a reference to an item stored in the list around and expect that reference to stay stable. That is not the case in Qt 6 anymore, and is one of the places where you need to be a bit careful when moving over to Qt 6. Qmap and Qhash also got a lot of changes and are actually completely new implementations in Qt 6. In Qt 5, Qhash and Qmultihash were basically the same class, the same for Qmap and Qmultimap. We've separated them in Qt 6 in line with what also the STL does. They don't inherit from each other anymore, and they're not using the same, so that you can't accidentally insert multiple items into a Qhash or into a Qmap with the same key. QMap and QMultimap are implemented on top of standard map, standard multimap. So you can actually move from and to a standard map into a QMultimap or QMap. And what they add on top is the implicit sharing that we have with all our Qt containers. With QHash, we have been looking a little bit at the same thing. Should we go and implement it using standard unordered map? In the end, we decided to go for our own implementation there, a full brand new implementation using open addressing, because we saw that we could make it a lot faster than what is possible with standard unordered map, and we could actually also lower the memory consumption quite a bit. You can see this here. This is some benchmark results, basically averaging over lots of different operations in QMap. QHash, sorry. And you can see the QHash in Qt 5 and standard unordered map basically being there at the top in terms of performance, so slowest. You can see our QHash in Qt 6 as light green, and comparing it to one of the best implementations out there, the TSL sparse map, we're pretty much almost on par. Sparse map is something we couldn't use because it has some problems with the repeated insertions and removals. It's not built for that, something that a general purpose container like QHash and Qt needs to be able to tackle. Also on the memory consumption, you can see that we have reduced that significantly. Almost for an int hash, we've basically cut the memory's usage by a factor of 3. For hashes that store larger items, it's a little bit less, but still very significant. On the Unicode side, Unicode and string classes, we've done finished changes that we've actually started already doing with Qt 5, and we couldn't completely pull through because of compiler and platform limitations. All text handling now in Qt 6 is Unicode base. UTF-16 is the default string encoding for Q strings, and UTF-8 is the storage format that we're using for all I/O operations, basically. All our source code is assumed by default to be UTF-8 encoded. You can override that and tell the compiler it's something else, but QMake, when you use Qt and together with QMake or CMake, we will assume that by default that the source code is UTF-8 encoded. And that simplifies some things in how you use how you write your source code. You can avoid lots of Q string from UTF-8 and those kind of things in many cases. We've cleaned up the string related class and tried to get to a more consistent set, where we have now added a UTF-8 string view. We've made Q string view complete, and finally, we've also moved legacy encoding support out of Qt core. So things like Chinese legacy encodings, Asian legacy encodings, Latin 8 or something like that. For those things have moved out of Qt core, and we are limiting ourselves in Qt core to Unicode so encodings and a few other things. The string class is the set that we're now having. We've changed a bit Qt byte array. Qt byte array now assumes ASCII only, and not Latin 1 anymore. That's what we assumed for some of the character operations in Qt byte array in Qt 5, which is inconsistent with the premise that everything is UTF-8. So we've reduced it to the common set to ASCII, and in principle, Qt byte array is meant for storing and reading binary data. For UTF-8, we have the UTF-8 string view class as a wraparound to tag UTF-8 specific class. QStringView has been, the API of QStringView has been completed and supports all of the const methods of QString. We've removed QStringRef, which was something rather similar to QStringView. It's still available in the Qt 5 compat library in case you're still using it. This is a new library that we've added. We've changed regular expressions. QRegExp has been removed in Qt 6 as the old regular expression class, and we're now using QRegular expression, the new class that we've introduced in Qt 5 everywhere. It's much faster, much more compliant with Perl regular expressions, and it's based on PCIe too. In terms of text conversions, I talked about that. We moved some things out, and we have a new API called QString encoder and decoder. It's value-based, stateful, and that does support most of the conversions that you will need to handle in your application. Qtext codec has been removed and is available now in the Qt5 compatibility library as well. So those are some of the changes in Qt core that we've been doing. Let's move a little bit onwards. The next big change that we've been doing is when it comes to our property systems and bindings. You probably all know about bindings in Qt Quick. In Qt Quick, you can declare a rectangle, give it a couple of properties, and you can bind, for example, the height property to the width property. So whenever the width property changes, the height will get adjusted automatically. And the border, that's a tenth of the height. The nice thing and the fantastic thing about bindings in QML, and what makes QML so successful in Qt 5, is that they can be arbitrary expressions. And Qt, the framework, will take care of making sure that those relationships hold at all times, so that whenever the width is modified, height and border will get adjusted in this case here. With Qt 6, we will have been thinking about how we could bring this over to the C++ side of things. How can we bring this binding engine that we have in Qt QML and Qt Quick all the way down into Qt Core? And that has been one of our goals, because we've been seeing that this binding engine is one of the best things that we have in QML. And how can we bring that to all of Qt? So how can we extend existing properties in QObjects with support for bindings and add binding support to any other class that you want? We've also seen through the experience we had in Qt 5 with the binding engine that we have in Qt Quick, that there are a couple of things that we wanted to improve in terms of the architecture. We wanted to make the binding evaluation lazy. In Qt 5, they were always done in a push way. So whenever a dependency changed, all the bindings that were using that property on the right-hand side would get re-evaluated immediately. That led to a lot of binding re-evaluations, more than were needed. So we wanted to make sure that they only get re-evaluated once you ask for the value of the property. And we wanted to make it fast. So those were some of the goals that we had. What we came up with is an API that looks this way. And that was something that will work, and that's available in Qt 6 now. You can add Q properties to any data structure that you're having with a certain type. And you can then, for example, set up bindings in the constructor. This is basically the same example as the one you saw earlier, where you set the height to the width and the border to 10% of the width as a binding, and Qt will make sure those relationships always hold true. Now, how did we implement this? A straightforward way to do that would have been to just basically say, okay, we have a binding function inside the property class, and we have a data. And whenever there's a binding and you want to get the value, we just simply evaluate the binding and return the value from the binding. And when you set the value, you basically break the binding and set the new value, or you set up the binding there. The problem with this primitive approach is, of course, that it doesn't perform very well. It would force binding re-evaluations to happen every time you ask for the value of the property, which is not very good. So the reality looks a bit more complex. This is just giving you a little bit of a hint. If you want to see all of that, have a look in the Qt source code, where you can find everything. We basically have some binding data here, and we're basically then doing some lazy evaluation. If the binding is dirty, we evaluate it, and then we need to also, basically, if there's another binding currently evaluating that asks for the value of this binding, we'll need to tell it, okay, we are you depend upon this value here, and then we can return the value. So something similar, and in the set value, we also need to notify all our dependencies that the value has changed. There's a couple more details in there. Let's not go into the details. The next thing, of course, was that QObject complicates the picture a bit. We have an existing property infrastructure in QObject, and we wanted to avoid breaking compatibility there with Qt 5. So the existing set property mechanism is something that we wanted to extend in this case. We want to make sure that we can do data hiding. QProperty itself, the data lives in the header file. For Qt, we need to move the data into QObject private, hide it so that we can have enough freedom to change our QObject derived classes without breaking compatibility. And of course, we also wanted to avoid any overhead if bindings aren't used. So the solution was to basically make the binding support a simple addition to the existing property system in QObject. We add a getter for the binding interface, so you can get a QBindable, which is basically an binding interface for a certain property. The naming convention that we're using is to call that the bindable of that property. We extend the QProperty macro that's there to help mock find those things and make them introspectable with a bindable tag. And then we use a macro QObject bindable property to implement the data storage. The advantage with this scheme is that it's very low overheads if bindings aren't used. We only use one additional pointer in QObject private, and that's it. Here's how you implement your own object with support for bindable properties. You derive from QObject. Well, you do the QProperty macro as you would have done before. The only addition is the bindable at the end. You declare the storage for the bindable object with as X data in the next line. And then you have the public getter, setter, and the getter for the bindable interface. And that's pretty much it. So the extension to what you had to do before in Qt 5 is rather minimal. Move over, next topic. QMetatype and QVariant. Those are some things where we have also done a lot of changes in the internals behind the scenes. We've moved over to a common backend for QMetatype and QVariant. That was not the case in Qt 5. So QMetatype couldn't handle the built-in types that QVariant could handle. Now the support is symmetric. QMetatype can finally handle all the built-in types. And the support for non-built-in types is actually much more transparent and faster. So we have a much faster code path there. QMetatype just contains a pointer to a handler struct. The registration is automatic now, not manual anymore. And we've deprecated at that time also the integer-based type ID. You just use QMetatype directly to identify the type that you have in there. This is done using, as I said, a QMetatype interface structure, and QMetatype just holds a pointer to that interface. That interface has all the introspection information that we need for any given type that we want to introspect in Qt. We've done improvements to the mock, also there to improve performance. These are things behind the scenes. You shouldn't even see them as a user at all. But we now store and resolve the required type information at compile time. There are no more string lookups for type information that we still have to do in Qt 5, which means that resolution of methods, of signals and slots is faster and more efficient at runtime in Qt 6. And of course, we've also added their support for those bindable properties that I've talked about before. And you can dynamically add and remove bindings through the metatype to the introspection interface of QObjects. Let's move a little bit beyond Qt Core. Qt Concurrent is something that has gotten a lot of attention. We're seeing that multi-threaded computing is, of course, getting more and more important moving forward. And we wanted to make sure that we have things in place there, that Qt Concurrent is up to the job and done a lot of changes in there so that you can now use it in a much simpler way. We have a support now for simple changing of computations using QFuture. Then you can attach failure and cancellation handlers. You can convert signals to QFuture objects using QFuture connect. We've added a promise class so that you have support for promises. And you can also, it also supports custom thread pools now. Here's a quick example how you can easily use Qt Concurrent these days. If you have something where you want to asynchronously and in a threaded way download things and then download something from a URL, then convert it to a QImage and show it. Using Qt Concurrent, you can simply do that. You basically run the download method using a URL. Once it's done, then it'll load the image and then it'll show it. And then you can also attach a failure handler using the onFailed method. Very simple and very easy to use nowadays. There's some further improvements on the non-graphical side that we've been done. Multiple things in Qt Network, SSL, TLS improvements. We're enabling HTTP2 support by default now. And you can easily write now your own plugins for Qt Network Access Manager. I've earlier mentioned the Qt 5 Compat module as well a bit. This is something that we've added now to ease the porting to Qt 6. And it contains some of the classes that are deprecated in Qt 5. This should make it much easier for you to move over to Qt 6, and then you can see that you, at your own time and pace, maybe remove the dependencies onto this module. Moving over more into the graphical side of things, we've done a lot of work on pointer events, anything mouse, touch, tablet, and unified the handling of those with one common base class called QPointer event. We have done specializations for mouse, touch, tablet events. The great thing for you is that this is very much source compatible, but it brings those classes together with common data and tracking of input devices so that we can, behind the scenes, make much better decisions on what to do with the input that comes from the end user. This really resolves the recurring issues that we had, for example, with touch handling in complex controls. For example, something like you have a touch-enabled controls inside the flickable in QML and Qt Quick. You wanted to have multi-point touch there with different items and you're touching different items at the same time. Those use cases are now supported in a much, much better way. Now, let me move over to the other really big topic and change that we've done mostly behind the scenes for Qt 6. And these are the changes that happened in the graphics area. With Qt 6, we've completely rewritten and changed our graphics architecture. Qt 5, we basically had two paths that you could use for graphics. One was software rendering and rasterization, used mostly for the Qt widgets, but also sometimes for Qt Quick. And the other one was based on OpenGL and using OpenGL as the API to do hardware accelerated graphics. With Qt 6, we've moved and changed that completely. As you know, the world has changed. OpenGL is not the only graphics API in town. Apple has been introducing Metal and even gone as far as deprecating OpenGL on their platforms. Microsoft has Direct3D, and on Linux and on Android, Vulkan is coming and is probably going to replace OpenGL over the next years, at least to a large degree. So we are now dealing with a multitude of graphics APIs, the same way as we're dealing with a multitude of operating systems. Qt being a cross-platform framework, of course, this is a challenge that we need to tackle. So we've added and we've implemented now over the years, as you saw a preview of that in 5.15, what we call the Qt rendering hardware interface, a thin abstraction layer on top of those platform APIs that basically abstract the different 3D graphics APIs, and all of the graphics related things in Qt 6 are built on top of this rendering hardware interface nowadays. We still have the software path next to it using Qt Painter, but anything that's hardware accelerated is using now the rendering hardware interface. We have built on top of that the Qt Quick Scene Graph, and then a unified 2D and 3D Qt Quick support on top of that. That actually simplifies how our graphics stack is working and gives also for much better experience on your side and much better performance. To complement that, we've added what we call the Qt shader tools. This is a separate module that allows you to write shaders, vertex shaders, pixel shaders, compute shaders in a cross-platform way using GLSL, the Vulkan style GLSL, and then cross-compile it to all those different graphics APIs. You can do that at compile time or at runtime. And finally, of course, on top of that, we have our tools, Design Studio and Qt Creator, that are also then, integrating with all this architecture. So the rendering hardware interface is now an abstraction layer for all those 3D graphics APIs. It abstracts all the graphical objects that we need, materials, meshes, shaders. But it is, for the moment, an internal API tuned towards the needs of Qt. It integrates deeply with our platform and Windows system abstraction layers. And of course, Qt Quick 3D, Qt 3D, they are all fully ported to the rendering hardware interface and built on top of that. This has been one of the largest changes that have been going on underneath the surface. And as a user, you don't really see a whole lot of that on the outside, except that we're now using those graphics APIs behind the scenes. Shaders tools, as I said, the module to support cross-platform shaders. You write your shader once and you recompile it to all those graphics APIs. You can do it at build time or at runtime. So you can, if you want to, dynamically generate shaders at runtime and then compile them for whatever you need. Or you can bake those shaders offline at build time and generate a cross-platform shader using those shader tools. What's very important now to remember is that Qt 6, this means that Qt 6 uses the native graphics API of each operating system. So we are using Metal on macOS. We are using Direct3D on Windows. And on Vulkan-enabled devices on Android, we're using Vulkan. Qt Quick 3D is something that we've been building over the last years. You've seen previews of Qt Quick 3D already in 5.14 and 5.15. With Qt 6, as I said, it's now built on top of the rendering hardware interface, which simplifies a lot of things and makes it possible to much more efficiently also combine 2D and 3D in one scene. We have one optimized scene graph that handles both. Qt Quick 3D at the same time has gotten a lot of new features and functionality. We've gotten much better in doing physics-based rendering and supporting those kind of materials. They look as they're designed, as you can see, for example, with one example on the right-hand side. We've greatly improved the support for GLTF2. We support the full base spec and most of the common extensions. And our goal is to further work on that, make sure that it's really easy for you to import any 3D graphical assets into Qt Quick 3D and use it there inside your scenes. We've also done work towards the desktop. And one of the big things there has been to make sure that Qt Quick can actually be used in a good way on the desktop. So we want to make sure that the Qt Quick controls can look and feel native on Mac OS, Windows, and Linux on the desktop platforms. So we have added that support for that. They're now natively stylable. You can see that on the right-hand side. This is Mac in dark mode, or you can also get something here, a different style. All of that looking native on those platforms. Moving forward, we'll also make sure that the same applies to the mobile platforms. That is still work in progress. But we want to make sure that we support those, the native look and feel of Qt Quick on all of those platforms in the future. Tuukka already talked a little bit about CMake. This has been one of the large underlying changes. We've changed the build system that we're using to build Qt itself from QMake to CMake with Qt 6. There have been a lot of reasons why we wanted to do that. Better performance, better support, but we also saw that QMake, that this is the build system that most of our users nowadays are using when they have larger projects. And this really brings also a much better CMake support than to our end users, because we're using it ourselves in a much more. QMake is still around and you can still use it for your own projects. It's supported in Qt 6, but we're not using it ourselves in Qt anymore. Let's have a look at what we're supporting in Qt 6.0 right now. On the host side, we are supporting Windows 10, macOS 10, 15, and 11, and recent up-to-date Linux distributions like Ubuntu 20.04, CentOS 8.1, SUSE Enterprise Linux 15, OpenSUSE 15.1. On the target side, so that's when you're cross-compiling, we support, of course, all host platforms so that you can deploy to all of them. You can deploy, we are supporting Yocto 3.1, iOS 13 and 14, and Android 28 at build time, 21 at runtime as the minimum requirements. There's some roadmap for the other platforms. We are looking into getting also a native build for macOS on ARM. Timing is not quite clear yet, but we're looking into providing that to you as well, of course, as a cross-platform toolkit. We want to make sure that we can support that. Yocto 3.2 is planned for Qt 6.1. And we'll also add back the real-time operating systems QNX and Integrity, where we're planning a technology preview with Qt 6.1 and the full support with Qt 6.2. The roadmap, as you know, we released Qt 6.0 in December 2020. 6.1 is planned now for the end of April. So we're moving a little bit, releasing it a little bit earlier than we used to do over the last years with the Qt 5 series, but we're still keeping a half-year release schedule. But we're now trying to move into a more of a spring, autumn thing instead of before the summer break and before the Christmas releases. So 6.1 will come out around end of April. 6.2 is planned for the end of September. Some of the things that we're planning to do there, and this is just a very rough outlook. Tuukka talked already and gave you the roadmap of when the remaining add-ons are planned to appear in Qt 6. They will be delivered mostly through the package manager when they are ready. We are working on making most of our properties in Qt bindable. This is something work that has not yet happened due to time limitations. We're looking into widening the C++ API for Qt Quick and Qt Quick controls, so you can also integrate that better with C++ projects, use it from C++ in a better way. There's some larger changes planned for that will improve the QML performance. And then, of course, improvements on the native styling for desktop, mobile, accessibility there, and more graphics features, especially also there in Qt Quick and Qt Quick 3D. With that, I'm getting to the end of the presentation. If you want to know more, especially also about how to port over to Qt 6. There's a webinar upcoming, how to migrate to Qt 6 on March 24th. With that, I'd like to thank you, and let's now take any questions that you might have.
Yeah, and it seems that we have already a couple of questions there. Happy to have more. One question was about that. What about those modules that don't have a clear maintainer defined? Are they in danger of being dropped from Qt 6, for example, WebSockets? So, well, first of all, WebSockets is in the planned roadmap to be supported with Qt 6.2. But yes, of course, if there is a module that is community maintained, and there's no, typically those are the modules that are not that widely used. So, and if the maintenance of that is not happening, then yes, it is a possibility that this module is not coming with Qt 6 support before somebody does it. That said, the package manager also gives the possibility of providing much easier than before access to those additional components that are not fully supported but are usable in certain use cases. So in that sense, it's an improvement over the situation that it has been, and obviously it's even without package manager, you can of course just take the code and build. If it's an item that is not that much affected by the profound changes in Qt 6, then porting it, building it is quite simple, even if it's not a supported module. But as said, majority of the items are supported, and definitely we are looking at, okay, how much a module is used, and therefore how valuable it is, and we are prioritizing those. And so there isn't that much that is missing.
I think there's very little actually, in fact, that's missing. Next question, around Qt script. There are lacking features in QJS engine. I do believe that we've closed some of those lacking features in Qt 6.0. If there are more things that you need, we'd be very happy to hear about your use case and what your needs are, and then we'll look into getting those implemented in QJS engine, as that is the much better JavaScript engine than Qt script was, and get those implemented during the worked out 6.1 and 6.2. So let us know what you're missing, and we'll listen and see how we can get those things implemented.
Yeah, of course, there's also, we do have a Python support in Qt. So some of the things, so if you have a really complex and complicated script, so if you are going towards, let's say, machine learning or that kind of things, it is probably so that you might want to consider looking completely different scripting language than JavaScript. But that said, of course, if you have some things and if your preference is for JavaScript, we understand that not having Qt script is a problem. But that's I think also in some cases Python might be better choice than JavaScript.
But I think for application scripting, that's where Qt script has been traditionally being used. A lot of the APIs are there. As said, it would be great to hear about what people are missing. The next thing, there was a question around WebAssembly. Tuukka, do you want to answer that one?
Yeah, sure. So WebAssembly is we are looking into it. We have some work ongoing. It doesn't have yet a committed timeline. So obviously it's supported with Qt 5.15. So it's one of those items that we are working on, but it was not mentioned because we don't yet have a full plan on that. Yes, on the WebAssembly part.
Okay. Next question is around multimedia. Maybe I'll answer that one. So yes, we have plans to include Qt multimedia in Qt 6. It's not there for 6.0 because we have been seeing that the module had some problems. I mean, the cross-platform coverage was, let's say, not consistent. So some features were available on one platform, but not on the other one. And it was very hard for our users to actually find out what's working on the different platforms and where they need it. So we are now looking into re-architecturing that actually is something that I've put personally onto my plate. So I'm working on that right now. I've been working for the past couple of weeks onto cleaning that up and doing things. What I do expect is that Qt Multimedia might have a few more API changes than some of the other modules moving towards Qt 6, but we do intend on supporting that, and we'll hopefully have it ready in time for Qt 6.2.
Yeah, then we have a question about controls and desktop in general. It's a longer one. So basically, there's a couple of things. So are we planning to recreate some of the Qt Quick Controls 1 types like 3-view? There already exists some of that that can be used. But in a sense, let's take if we take a more generic answer, that we are planning and we are looking in that, okay, how Qt Quick can really be properly used in the desktop. The styling, of course, being there, one of the things, accessibility being another important item, and yes, of course, the controls as well. So we do intend to have the most commonly used controls available. In addition, we want to create a way that these more, let's say, more special purpose controls could be easily available either through the tools or as a framework components coming from different sources, so that it would be possible to use. So widget is fully supported on the desktop, also with Qt 6, and that's all good and fine. But there are certain cases where Qt Quick is also valuable, and for this we do want to improve the support.
Yes. So there's a couple of things on our long-term roadmap, and we are now talking a little bit long-term. So this will most of that will not happen in 21, but will probably come in 22 or something like that. Is really to make sure that we fully support all the use cases that people have on the desktop, also for Qt Quick. We've now learned a lot on how we can do that. We want to make sure that the integration with native things are there, so that you can use the native dialogues, for example, on the platforms, or both on desktop and mobile. There's also the question of, for some of our users that want to rather use C++ than QML, how can we open that up a bit more? And those are things that we're working on, but it'll take some time until we have it all in place. But this is the direction we're going, in addition to, of course, also continuing to support Qt widgets as we have always done.
Then there are some questions related to the Apple platforms. I jumped over, Lars, a few, but so basically combining these two Apple-related questions that we have now. So basically, that there's also a question about the OpenGL. So you can still use OpenGL on Apple platforms. It is just that since it is deprecated, and actually it is also that in many cases Metal provides better performance. With Qt 6, you can use Metal, and that's the default. But it is still, if you want, you can still, of course, use OpenGL on Apple as well. There's also another question that does Qt work with the Rosetta emulation layer on the new Apple Silicon? Yes, you can run Qt. There are, like, in general, in the Rosetta emulation, there are some parts that are problematic, and those, of course, are problematic also for Qt, but many things work nicely. Qt is one of those, or Qt-based apps are one of those that have been used, and even when Apple was presenting Apple Silicon, I don't know if any of you were following some of those examples that were running there in the conference were actually Qt apps that were demonstrating how nicely Rosetta was running. Oh, unfortunately, they didn't promote Qt in the process, but yes, Qt works through the Rosetta for most parts.
Yeah. So other questions. web view. I think this is one of those modules that we're still looking and examining what we want to do with this and how to bring it back.
It's planned to the 6.2, even though it's
planned for 6.2.
It's one of those that we have sort of like we have captured as an important module that we do want to bring. So it is yeah, it's coming, but not yet done. So
glitch in my me remembering things.
Well, it's correct in that sense that we haven't done anything yet, other than said that this is something we need to do for 6.2. So
okay,
for the review. So
there's a question of the documentation for the desktop style. I think that they are documented actually to some extent, and there's not much you need to do if you just use the Qt Quick controls in Qt 6. You'll get the desktop style on desktops if you want to. There's a question about how exactly the workflow improves from designer to developer. I would say that goes a bit beyond the scope of this talk, and we've had specialized sessions around that.
Actually, like so it's very soon we have this designer, Qt Goes Word designer thingy. It's around this time. I will need to check the exact date, but there certainly there you can see this. This is a topic of exactly that event. Yes.
Sorry to interrupt. So that event is happening tomorrow, and you can still register for that if you'd like to find out more. So that's Qt Goes Word design, and registration is still open for that. It's a free event.
Yeah, great, thanks.
Okay.
And then there was a question about the Python bindings. Yes, that's already available, so you can use it with 6.0 as well. So.
Yeah, Python bindings are available, and they'll for 6.0, and they'll generally follow the Qt release schedule. So there will also be LTS versions of that for Qt 6.2. There's a question around books around Qt 6. No, there are no books available yet. Let's see what comes there. I'm not quite sure about any concrete plans.
Then there's a question about Qt Creator with multiple monitors. That should be already possible. So at least in the most common use case, you can do that. But of course, there might I don't know what is behind the question, because it's to me it is supported that if you have multiple monitors in your computer, you can partition creator parts and move those panels around, at least to some extent.
Yeah, if there's things that are not that where you'd like to have more flexibility, it would be great to hear what the need is, and you know, right, as always, the best place to drop those thoughts are on bug reports qt.io.
That was pretty much all the questions.
Yeah, we can
so
maybe
far.
wait for.
Some are typing more, so but I think those were pretty much.
Yeah, maybe we'll wait for a few more seconds before. So if someone's typing.
But yeah, in general, to recap the upcoming, so we have a lot of messaging and webinars and events coming. So please follow the Q.io. Like Sala said, we have the virtual designer event tomorrow. We have the migration to Qt 6 webinar coming. There's also a lot of other things coming. So there will be ways to join also more of the events in the coming months.
Yeah, in fact, the migrating to Qt 6, everything you need to know webinar is now scheduled for the March 24th. There's a couple of slots available for EMEA, APAC, and America's time zone. So feel free to go to our website, and under live webinars, you can find and register for that. But it looks like there are no more questions coming in. So actually, yeah, no, there's just one that came in.
It's related to multi-monitor support. Well, it's we'll answer this offline, but it's as I said, multi-monitor support in general is working, but there are this. Yeah, I'll answer this later. And then there was a question about the webinars about RHI and shader tools. I believe we have at least those World Summit talks available as an on-demand. I guess we have those sessions. They probably are recorded and.
Yep.
Yes, those will be available shortly. Not all of those are available as of yet, but we're working through them, so they should be available during Q1 or even earlier in early February.
Okay, good.
Okay, I think that is all for today. So I'd like to thank you both, Lars and Tuukka, for the webinar, and obviously thank you everyone for joining. As mentioned, there's loads of other webinars coming up, so feel free to register for those. If you have any more questions that we didn't go through, please send us an email at info@qt.io and we'll answer them for you. But until then, I wish you a great day and goodbye.
Thank you.
Thanks.